Oh, that Mr. Hiller and his jokes he sends me over email. Oh, hey there. I see you're joining me for lunch. But before we get to lunch, let's talk about linear inequalities, because we've done that today, and now we're going to do it again. So as I made my way to Wendy's today, I realized that linear inequalities are everywhere. I realized that. And then as I went to order lunch, I thought, you know what? Let's see what we can do with this. So today I went and bought lunch at Wendy's, and I only had $6. So I was going to spend a maximum, keyword there, maximum of $6. And I decided, as I was there at Wendy's, that I wanted to purchase a combination of junior bacon cheeseburgers and large Frosties. Because you never know. I mean, somebody might want to come see me for lunch later, and they might want a Frosty, or they might want a burger. You never know. So I was just trying to be considerate and get, the most I could for my money, and think smart about it. So at my Wendy's, the price of a junior bacon cheeseburger is $1.79 each, and the price of a large Frosty is $1.99. So I thought to myself now, man, I could graph these and find all the possible combinations of cheeseburgers and large Frosties I could buy. So now, hopefully, you can see my computer screen. Here is my number of Frosties, and Y is my number of burgers, in case you didn't get that, just because of how this website works. So I said, well, hey, if I don't buy any Frosties and just buy junior bacon cheeseburgers, I've set F equal to 0, and then I divide by $1.79 on each side to get burgers, the price of burgers by itself. I could purchase about 3 1/3 burgers. So just 3 burgers max. And then I said, well, if I just want to buy Frosties, I could set burgers equal to 0, and then I would get around 3 Frosties max. So when I did that, I decided, hey, well, I'm going to graph this line. And look, here it is. And as you know, as you just saw from the PowerPoint, this shaded region are all my possible solutions. Now, stuff over here in the, this is the second quadrant. Anything outside of the first quadrant I can't have. I can't have negative burgers. I'm not going to buy negative burgers, or I'm not losing burgers or Frosties. So we're focusing on things just here in the first quadrant. So as you can see, I have a variety of choices here. And I have the slider here to show you there's different choices. So, and this means, right here where it says equals true, that means this combination does work. So if I decide I want 3 burgers and no Frosties, that's still in my budget. So when we press the slider, and it's going to go slow so you can see it, I can buy 2 burgers and 1 Frosty. That still works. I can buy 1 Frosty and 1 burger. That still works. I can buy 1 Frosty, 1 burger and 2 Frosties, and that still works. I can buy no burgers and 3 Frosties, and it still works. So there you go. That's a real-life application of how you can use linear inequalities to figure out. So now I bet you're all very curious. Well, Mr. Fink, what did you get for lunch? So I decided, since Mr. Hiller was doing other things and he didn't want to eat me for lunch, that I would get only 1 large Frosty and 2 bacon cheeseburgers. Look forward to the next video tomorrow.